basically we're seeing a certain problem in the digital goods, digital economy space, and we think that the solution would be something that could be described as a protocol for building open virtual economies and basically virtual production systems and virtual goods. Let's clarify the problem a little bit before we go into the solution. So why are we doing this? The first thing to understand is that we tend to classify we have many different classification schemes, and one of the most common and original is we have non-fungible tokens to represent virtual goods, fungible tokens to represent virtual currencies. It's an imperfect taxonomy because, well, all the taxonomies we have so far are imperfect, and there's no sort of industry-wide consensus quite yet. But, the problem is that, and this has become somewhat of a meme, right, is standard proliferation, especially with virtual goods. The types of properties and capabilities that we want to represent vary so widely that we end up having a standard per type of good. And this is pretty ineffective. And so what do we do here to enable sort of interoperability between various types of goods? What's one solution? And it's pretty much this. We have a couple different standards that are extremely simple, right? A small, simple base, which is a good design pattern in general. And then we have all the sophisticated, rich logic that that token represents. We place that in a quote unquote DApp, decentralized application. And with various applications interfacing with these few standards to represent digital goods, we are able to maintain the interoperability that that comes with the benefit of adopting a particular set of standards. However, we end up with this kind of other problem where the real utility of the virtual good exists in the application. It doesn't offer the same guarantees as the token, and the tokens are become mostly inert, inflexible data structures, and innovation on token designs is really just what's a more complicated, static, predefined structure that I can create, barring things like upgradability of contracts from the Ethereum world and the rug pulling opportunities that presents, right? But that's not to say that NFTs are good for nothing, obviously. They're still good for sprinkling that sort of decentralized trust into a platform or application. The parts that represent the more static, persistent items in a game or things you want to secure in that fashion. And because of that, they can still be used as a common knowledge base for interoperability. If you want to, say, transmit say a character clothing for an MMORPG between games, utilize NFT interoperability to do that, right? But what NFTs are missing is that while we can express a certain set of common knowledge to enable interoperability, the question becomes, what sorts of knowledge can we express at that level? What's the extent and sophistication of the language that our NFT designs give us? And basically, the answer depends on the schema of the particular NFT standard that you're using. And so what do you do if you want to innovate and enable new types of common knowledge? Well, the answer is really that you have to create a new standard in a new platform. So we think about what digital goods are today versus what they could be. And one thing that really makes sense, especially if we think about analogies to the physical world, is that there needs to be more dynamic aspects of them, right? Even items I purchase at a store, I could burn them if I wanted to. So burnable tokens, okay, so we have that. I could also modify them if I wanted to in ways that the creator an inventor had no way of conceiving, right? So there needs to be a way not only to enable people who hold the token or digital good to operate within the bounds of the predefined schema, but a way for them to change the schema itself. They need to get outside of the token and be able to modify the boundaries as they see fit, while also preserving a certain set of fundamental invariants. True digital goods, they don't require some sort of separation between the ways they can be used and the underlying data structure, right? Instead of sophisticated applications operating on dumb data, why not just programmable and economic data structures that carry around their rules and enforce them regardless of the context? Something like this would allow for a lot more adaptability and flexibility when designing various types of protocols that operate on and are powered by virtual goods and virtual economies. To do this, we would need something that is also internally expansive. To refer back to what I said about changing the boundaries, well, we should be able to basically get inside of the digital good and change it as we see fit, because digital goods exist at multiple levels of abstraction. An art piece is a digital good, but so is a collection of art pieces. And how do you personally want to organize your particular crypto art collection? Might be different from someone else. That may require changing the internal structure and adding new substructures. So it needs to be internally expansive. And with all of that, it still needs to be externally composable so that we can take advantage of the meme that has been circulating today of DeFi Legos to more abstract and general virtual good Legos or something, right? But they're more dynamic. We need to be able to put them together in different ways while also evolving them and changing them independently. And all of this is difficult, not only because of, we have to build based on what already exists and technological constraints, but also economic constraints. And the information economy doesn't make it easy to innovate. Information goods, specifically goods valuable purely for the information they contain, are public goods. More accurately, they're eventually public goods, because if you write something personally, it's a private good, right? Until you share it, and then it eventually becomes more and more public. And this is, for example, why piracy is so easy and so popular. They're also durable goods. It's hard for an information good to depreciate because the substrate or the object on which it is realized doesn't impose any sort of limitations on its reproduction. It's zero cost to reproduce an information good and duplicate it. And they're also experience goods, which means that we don't necessarily know ahead of time how to value them. Information goods are hard to value without consuming them. I'm not going to, for example, buy a book, or I'm less likely to buy a book if I know nothing about its contents, how it's written. Of course, there are solutions, but the solutions don't necessarily make it easy either for a robust digital economy. To solve the public goods problem, we've come up with many different solutions. Most of them introduce some form of anti-competitive dynamics. We have, for example, the increasingly restrictive and somewhat toxic intellectual property. We also have digital rights management, DRM software, which does help to some extent, except for the fact that the producers have to continuously succeed every single time at preventing any sort of copy or piracy, whereas someone on the other side needs to only succeed once in breaking the DRM, however it's implemented. And that also introduces a sort of misaligned dynamics in relationship between producers and consumers. Experience goods are, the problem of experience goods are better solved than the other two because we can get, say, previews of information. You like think of Amazon and the fact that you can look inside the book, and we can get reviews. Think about Amazon again, who provide a verified verified purchase flag on certain reviews to indicate that they're more trustworthy. But in general, the fundamental properties of information goods lead to a nice phenomenon called market failure, right? These are not healthy properties for a robust market. But we believe that there is a way around this, utilizing and building off of and rethinking what we've discovered within the NFT space, where digital goods, to be truly portable, need to be outside of networks, outside of platforms, and be basically introduced as first-class citizens of the web. And I have here the meta-market example of a Metatoken, which is which demonstrates certain aspects of our design, which is primarily based on this decentralized digital good implementation. And basically, we can see that the Metatoken is represented by this boundary here, and we can implement microeconomies within digital tokens that can exist across the web, outside of one particular network, or distributed in parts across various networks. And we can basically have these tokens or metatokens carry around their own markets and their own dynamics. And this is kind of one of the core parts of our design. The Metatoken is one part, and then the universal reserve is the other part, which is MKT. And so we can see here that there's a sustainability loop implicit in every Metatoken, where the reserve that's built up from the meta market economic processes can be infused into any quote unquote NFT, which we're calling metatokens, can be infused into any metatoken to produce a supply based on your particular minting logic, basically your token economic policy. This can be then traded in secondary markets and interoperate with any other microeconomic token. And we also see that as one's token is circulated back into the community for interactions, MKT revenue is produced as well. So we have this loop here that is compatible with any other external market that can interact with simple fungible tokens, right? And this is how we combine. This is basically our design for something that can carry around all those dynamic properties, well-defined boundaries, but configurable at the policy level. The use cases for this include social tokens, for example. Those are becoming popular. Markets that exist across various games, even if those games are developed by different organizations. It could be used to infuse governance capabilities at the content level. So one example I use a lot is a magazine, which may have editors. It may allow people to submit personal opinion pieces, and the governance could be used here. This token could be distributed to governance for, say, a select group of people to have decision-making rights on which articles get in, right? It can also be used for community rewards, depending on what type of behaviors you want to see in your community, or even create promotional deals where promoters submit proofs in return for this MyCoin supply. They can later be exchanged for MKT or any other token through secondary markets that we also facilitate the creation of as well. So that was the dynamics of the Metatoken, and so how does this work, and how does it exist across networks, right? Well, this diagram here shows a bit about the token architecture, and we see that there are really two boundaries or spaces within within a Metatoken, inspired by operating system design, this sort of separation. And we call it meta mode for the meta kernel, and then hodler space, right, which is what you would think of as user mode in an operating system. The schema uses a semantically rich data definition language that is also versioned for updates, and it's automatically verifiable and enforceable. So you could think of it as an executable semantics that's easy to write. It defines the data structure, the internal data structure, and the constraints. Within the kernel is also a role, what I call here a role operation map, which allows you to create sophisticated permission schemes based on various role types. So you could have, say, for example, a public role type where anyone can interact with your token to perform certain types of operations, but not others. The render and control engines exist across these spaces conceptually because they can be used to interact with both with the token at all levels. But these render and control engines are also defined with the data definition language, so that any client, any sort of consuming device can automatically read and understand how to render the token in various environments. So you might have a rendering engine for the browser, and you might have one for, say, some sort of VR device. And the control engine is similar, but enables you to interact with the token based on where it's sourced and where is its verified or verification engine, so to speak, or blockchain, or across blockchains, right? So I actually already talked about these things. So, oh yeah, the final thing to mention about Metatokens is that these various rules, it's so abstract, right? These various rules that are possible can actually be installed into the Metatoken. So if I wanted to implement, say, the custom currency on the previous slide, that could be a simple few-minute installation of a policy of a certain type of economics that someone else has already published on the meta market. And because we use meta a lot, right? And there's a reason for that, because policies themselves that can be installed in tokens are also digital goods. And so similar to how you can infuse your digital creations with microeconomies and markets that can exist across the web, you can also publish your policies in the same way and implement various types of revenue generating streams, which enables new ways for, say, open source developers to generate income. The other two elements of this protocol are a hierarchical curation with a generalized token curated registry design. And basically, at the top level, we may have top level topics, but these are namespaces that change all the time based on the preferences of the people who are doing the curation. And this allows us to kind of enable a better way to quality control, as well as discover new goods based on your interests and topics and subtopics, etc. There's also, I guess it's best described as horizontal curation, which is through what we're calling the impact-weighted attribution protocol. And basically what that does is it creates relationships between digital goods, right? And this is very important because we often get inspired by one creation or by many creations, and then we want to create something new that's a synthesis that's greater than the sum of its parts, right? However, everyone who created the things that inspired you added value to your creative process, and by virtue of that, it's very transitive. Whatever value your creation delivers to others, in part, is due to the many people who created the things that inspired you, right? So we need a way to capture that, and that's with this automatic attribution based on relevance and basically archiving processes that curate these types of basically giving credit where it's due. Okay, and then so that's what IAMM stands for, the Information Attribution Meta Market. And this is just a quick roadmap. So this month we are releasing our new website because we rebranded and renamed, and open sourcing selected code repositories that have been in development for the past six or so months, including the reserve currency, and testing one of the initial apps on it. And next month we'll open access selectively for people to acquire the MKT, which will be used later as the universal reserve. It also comes with certain rights attached to it, but you can read more on the website for that. And in June, we release an alpha version of the application itself. In May, the protocol, the Metatoken protocol, solidified. In July, we integrate the impact attribution protocol into the marketplace. We release the hierarchical curation in August, and then in September we're live. And then, if you want to reach out, we have a new Twitter account we just created a few days ago. It's got like 11 followers on it, so you're more than welcome to follow if you're interested. We also have a Discord server, and our website will be announcing on Twitter when it's live and finished. And then if you want to talk to me directly, this is my Twitter handle and this is my Discord handle.